Let's try to understand change in case of a function given by y equal to fx. Let's say the value of y at some value of x equal to x1. So what is the value of y at x equal to x1? Will be obtained by substituting x1 in place of x here. Then you will get the corresponding value of y. Let's call that y1. So we'll have value of y at x1, which is represented by y1 here, is equal to f of x1. Similarly, we can find out the value of y at x equal to x2 for some change in x. Now, you can see the value of y at x2 represented by y2 is f of x2. So our change in y as x goes from x1 to x2, so our change in y will be y2 minus y1. So what we are saying is y is a function of x, y here is a function of x. If x changes from x1 to x2, then correspondingly y changed from y1 to y2. Our change in x is just x2 minus x1, and change in y is y2 minus y1. This is the corresponding change in y, which is represented by this value, delta y equal to y2 minus y1. We can further investigate this change in delta y in more detail by writing y2 is the value of the function at x2. So we can write y2 is equal to simply f of x2, and y1 is the value of the function at x1. So we can write here minus of f of x1. So far, in the function y equal to fx, we have changed the value of x from x1 to x2, then change is marked by x2 minus x1, which is delta x, and there was corresponding change in y. Let's say y changed from y1 to y2, where y1 was fx1 and y2 is fx2, is given by delta y is equal to y2 minus y1. Now let's talk about average rate of change of y with respect to x, and let's see how it is defined. So for a function y equal to fx, the average rate of change is defined by delta y by delta x. This is the average rate of change of y with respect to x, given by y2 minus y1 divided by x2 minus x1. Let's try to understand it graphically, what average rate of change of y with respect to x means. We have on this line x-axis, and on this line, let's say it is y-axis. And we have a curve in which we have the variation of y with respect to x represented graphically. Let's suppose our initial point of observation was somewhere here, x1 initially, and as the x changed, it reached some value here. So we have initial value x1 and it changed to x2. Now the corresponding change in y can be obtained by observing the corresponding values on y-axis. So at x1 the value of y is y1, and at x2 here the value of y is y2. Now let's try to understand what delta y by delta x individually mean. Our delta x is this much, delta x. Similarly, y changed from y1 to y2. To start with, our value at this point, let's call this point A and let's call this point B. Basically, going from x1 to x2, on the curve we are going from point A to B. After joining the points A and B of the curve by a straight line, we can observe, I call this point C here. In right angle triangle ABC, you can see delta y by delta x is tan theta of this angle. Let's call this angle theta. So we have tan theta equal to delta y by delta x. Now, if this angle is theta, then this angle would be theta 2, and this is actually the slope of line AB. So it is equal to slope of line AB. So we have an interesting revelation of delta y by delta x graphically, that average rate of change of y with respect to x in the interval going from A to B is the slope of the line cutting the curve at A and B.